Hi everybody, myself Dr. Balamurugan, Associate Professor, Department of Electrical Electronics Engineering, KS Rangasamy College of Technology, Tiruchengood. I'm going to discuss about the special machine drives and how the circuit will be, how the machine will be controlled by using the power electronic circuit, and what are the modes of operation we will see in this upcoming slides. So this is the trapezoidal special machine drives, which is nothing but BLDC drives. The circuit diagram shown here consists of a supply, which is nothing but DC supply, which is connected with electronic commutator. That is nothing but an inverter. And second thing is which is interconnected with a machine. That is nothing but BLDC, which is monitored by using the position sensor. Here speed is monitored by using the position sensor. The speed feedback is given to the control block. The control block will generate the control signals to the appropriate switches, and the switches will be controlled according to that. So in order to sequence the switches conduction, there are two modes of operation. Let's we see the modes of operation. These are the two modes of operations, which is nothing but 2 pi by 3 angle switch on mode and voltage and current control PWM mode. Let's we see the 2 pi by 3 switch on mode. So this is nothing but 2 pi by 3 angle switch on mode, which is nothing but 2 into 180 degree divided by 3, which is nothing but the switching angle for which is given for every switches. You can see in the bottom of the waveform, the switching sequence is given. Two switches are connected in a single sequence of interval. The interval which is taken for each and every sequence is nothing but pi by 3, which is nothing but 60 degree. So the switches will be connected for 2 pi by 3 and the interval of every switches will be pi by 3. So here we will be getting the sequence of 2 switches which will be connected for every interval. You can see in the previous slide that the switches for every leg will be 2 number of switches and the conduction of the switches will be 2 number of switches. So for every leg, 1 number of switch will be active for conduction in every interval, that is for every 60 interval. So totally 6 number of intervals will be given. You can see first interval is here. So this is the first interval. So this is the first interval and this will be the second interval and this will be the third interval and this will be the fourth interval. Likewise, it will be going for a 1 number of cycle. 1 number of cycle is nothing but from 0 to 360 degree. So for every number of cycle, every switch will be giving we will be giving the gate pulse and one switch will be turned off. One switch will be conducted and one switch will be turned off. You can see here Q1 will be given the gating sequence and here you can see Q1 will be Q2 will be given the gating sequence in the second interval and you can see it will be connected for 2 intervals and in the third interval the Q2 will be turned off and Q4 will be given the firing sequence. So likewise the sequence of conductance switches will be going on for each every cycle for an interval of pi by 3. So let's see the second mode of operation. So here there are two modes in voltage current control PWM mode. One is feedback mode and another one is a freewheeling mode. So initially we will see the feedback mode. In the feedback mode, the same feedback is taken from the motor, which is nothing but the speed. So here the speed is sensed by using a position sensor. How the position sensor helps to sense the speed means it will senses the position of the rotor and the rotor will be given as the feedback to the decoder. So the decoder decodes the signals and that signals will be given to the appropriate controller and the controller will generate the PWM signals for each and every switches from the switch number 1 to switch number 4 and switch number 3 to switch number 6 and switch number 5 to switch number 2. That is 1 and 4 first leg, then 3 and 6 second leg, then 5 and 2 third leg. So for each and every leg, according to the position, the switches will be turned on and we can have the switching sequence for phase A and phase B and phase C. So you can see here the reference speed will be set initially, and according to the speed sensing, the reference speed, it will be the information will be compared, and according to that comparison, the PWM signals will be generated. How the PWM signal will be generated? Here you can see according to the reference speed and the actual measured speed. Here you can see that the omega r is nothing but the speed which is measured from the position sensor, and omega r star is nothing but the reference speed. The signal which will be compared in this comparator, and a current reference will be generated. So according to this current reference, three-phase current reference will be generated according to the decoder signal. So each and every phase will, we can say it as IA star, IB star, and IC star. According to that, this hysteresis band current band controller generates the PWM signal. That signal will be triggered to the appropriate switches. For example, for IA star, the corresponding hysteresis band current controller will generate the signal to either Q1 or Q4. Likewise, for IB star, the signal will be for Q3 or Q6. Likewise, for IC, for Q5 or Q2. Here, two signals will be compared. The measured signal IA, measured signal IB, and measured signal IC, which will be taken accordingly from the three phases which is generated from the inverter. You can see here, this is the feedback which is taken from the each and every phase, and it will be compared with the reference current generated from the position sensor output, which is connected with the comparator. So here two things will be done. One thing is, first thing is based on the reference speed, a current reference will be generated. Second thing is, according to the current reference, a feedback signal is taken, and feedback signal will be compared with that of the comparator, and by using the hysteresis current band controller, each and every PWM signals will be generated. That's all. The process is generation of PWM signals by using the position sensor feedback, which is taken from the trapezoidal PM permanent magnet machine, which is nothing but BLDC machine. So then we will see the next mode of voltage and current control PWM mode. So this is nothing but a freewheeling mode. Here you can see only one reference will be generated, and that reference will be controlled for each and every phase switches. So there we can have each and every leg will be having two number of switches. Here also you can see two number of switches will be connected in a single phase. For example, Q1 and Q4 will be connected for A phase, Q3 and Q6 will be connected for B phase, and Q5 and Q2 will be connected to C phase. So likewise, each and every phase will be connected for two number of switches, and you can see the Hall sensors which is used for measuring the position of the particular phase shaft, that is that motor shaft. So the position will be given to the decoder. The decoder will process the Hall sensor inputs which is taken from the motor, which will give the position of that motor. So according to that, the switches will be triggered based on the reference current generation. So here we call this type of mode as a freewheeling mode. So in summary, we have seen BLDC drives, which is controlled by two modes of control. One is 2π/3 angle switch mode. Second one is voltage and current control mode. So in voltage and current control mode, we have seen two types of modes. So this is the control for BLDC drives. Thank you for listening. Thank you.